Welcome all of you for Power Electronics webinar series, video number 3. In this video, you will going to learn about unit number 1, silicon controlled rectifiers. So before we will go head on this unit, those who are not see at the video number 1 and 2, the video number is 1 is a introduction of the power electronics. Video number 2 is a introduction of the power semiconductor devices. Different type of the semiconductor device, current controlled devices, voltage controlled devices. So like that one, the devices it will going to classify unipolar devices, bipolar devices, unidirectional current capabilities, bidirectional current capabilities, and then what is the symbol of that power semiconductor devices. So like the semiconductor devices it will go to classify. So please go through about that video number 1 and video number 2, then coming to the video number 3. This video number 3 it will going to give outline about the silicon controlled rectifier and the GTO, gate turn off thyristors. These two topics we will going to see about in that video. The outline of that presentation, the content it will going to cover, it is the showing that ones. It is there in your syllabus. Construction of the silicon controlled rectifier SCR, then static and dynamic characteristics of SCR, specification, ratings of SCR. Okay. Then followed by the triggering circuits. You will going to trigger the SCR with the help of that 3 different type of the method: R triggering method, RC triggering method, UJT type of the triggering method. Why do you go for that R instead of RC instead of that UJT? So what is the limitation in R? That's why you can go for that RC. What is the limitation is there? Then you can go for that UJT. The next one is a commutation circuits. Commutation means turn off the SCRs. How to turn off the SCR? So there are different type of the methods available: class A, B, C, D, E, like it is there. So generally it will go to classify into 2 methods: natural commutation and forced commutations. Okay, here is you will going to see about class C and class D. Another one is a protection of that SCR. So how to you can going to protect the SCR due to the over voltage and over current and the thermal protections. So why this is important about that protections? Then followed by you will going to see about that one more topic is called a gate turn off thyristors, GTO, gate turn off thyristor. Okay, and then their construction, working and application you will going to see. Okay. See this slide shows the symbol of that power semiconductor device consists of 3 things. One is a diode. Diode it is showing on that ones. So my arrow mark it will go to visible, I hope. So it's a diode. It consists of the 2 terminal. One is a anode, another one is a cathode. The power is a flow from anode to cathode. The arrow mark is also mentions anode current. It will go to flow from anode to cathode. It will go to flow. So across the voltage drop across that one's normally it will go to start with the 0.6. Another one is with respect to the different manufacturers, it will going to drop 1 voltage and 1.2 voltage. So like that the diode it will going to voltage drop it will going to take place. Okay, so here it is one more major things is it will going to flow only one way direction. Okay, only one way direction it will going to flow that once the power is a flow. That's why the arrow mark based the diode is symbol is mentioned. Okay, diode this is about it consists of only 2 terminals. When do you go for that SCR, silicon controlled rectifier? It will going to derived from that diode and one more okay leg, or it has that one more terminal. It is called a gate terminal. Okay, it is mentioned. Okay, this gate terminal it is used to you will going to controlled on only, you can't do off the controlled. Okay, so uncontrolled off device. Okay, then next one GTO. When you have go to the GTO, I want to turn off this gate terminals, I want to turn off that this SCR. So it is possible on the GTO. Okay, so very nice differentiation about that SCR and GTO. In the forthcoming slides I will going to tell about what is the difference between the SCR and the GTO. Okay, then next one, yeah, You have see about the slides, it's a common characteristics of that ones. Okay, this is symbol about, you have seen previously, symbol of the SCR and the GTO. The one, what is the difference between the SCR and the GTO? The SCR, it has that gate terminals. Okay, here no arrow mark. Okay, it is only one way directions. If I have see that one, there are two arrow mark is mentioned. So you will go to upward and downward. So this arrow mark, it is indicated to, you will go to on as well as off the SCR. And this is symbol wise differentiations, and then it has that a few of the common characteristics behind about SCR and the GTO. It is a current control device. Okay, then next one is a pulse triggering devices. It's a pulse based triggering devices. What is meaning of the pulse triggering triggered circuit means? So you will going to apply the gate terminals. Once you will going to apply a minimum current. So minimum current means it is equivalent to that latching current. Okay, once you will going to apply the latching current, after that you will going to stop to apply the current to the gate terminal. It will going to keep on conducting. That's why it is called the pulse triggered devices. Okay, so what is the current control devices? That one you will going to see about, you will going to learn about the forthcoming of the slide. Okay, in the slide of the static characteristics tabulation. Static characteristics tabulation, you will going to learn about the why it is called the current controlled devices. Okay. It's very simple to say. Actually, if I have see that one in the characteristics diagram, okay, you will going to apply the gate current. That is called the minimum of the latching current you will going to apply. So minimum of the latching current you will going to apply, not you will going to apply the minimum of the latching voltage or not that holding voltage. You will going to apply for the minimum of the latching current. That's why it is called as a current control devices. Current control device. Then next one is a minority carrier device. It's a minority carrier device. Bipolar voltage withstand capabilities, unipolar current capabilities. So unipolar current capabilities means it will going to permit for the unidirectionals. Triac is a bidirectional current capabilities. So bidirectional current capabilities for the triac. But the SCR GTO is a unidirectional current capabilities. The next one, the two more point I have mentioned in the slide, it is the difference between Thyristor and the GTO. What is the Thyristor and the GTO? You have, I will going to show with my mouse. Controlled turn on and uncontrolled turn off. That is called the Thyristor. Controlled on and controlled off, it is called the GTO. So this is a major difference between the SCR and the GTO. Okay. The next one is the rating of the SCR and the GTO. In the last slide, last video too also, I have mentioned about what is the rating wise difference between the different power semiconductor devices. So here you will go to once again I have show about that rating of that SCR and the GTO. If you have seen that in the left hand side, the Thyristor or SCR, you can say about that one. So it will go to power rating. The y axis is the power rating, VA rating or power ratings, watts or that VA you can mention, and then x axis is a frequency. Okay, the SCR it will going to available for that maximum 1000 kilohertz. It's a maximum available under 1000 kilohertz. Another one is the power rating is higher, 10 megawatt power rating is available on the SCR. When you have go for that one is a GTO, it's not available for that one is a 10 megawatt. Okay. So the second one it is mentioning about that one. So it is available GTO for that one 6 kV kilovolt, and then 6000 kilo amps it is applicable. The next one slide it will going to show you about that ratings of the voltage and the current. Just you can look it about that SCR 6000 volt and then 3500 amps. So what is about the frequency? It is just 1 kilohertz switching frequency. 1 kilohertz switching frequency. When you have go for that GTO, it's a 4000 volt, 3000 amps. That is a lower the compare with that ones. So the rating is the lower than the SCR, and then so switching frequency is higher than the SCR. This is one of the point. Okay, when you have compare the GTO with the SCR, so lower the voltage and current rating, power rating, and then higher the switching frequency. The GTO switching frequency is 10 kilohertz. So this is symbols of that ones of that thyristor and then GTO. Already I have show you the symbols of that one. When you have see about the characteristics diagram, both the diagram VI, this is called as a VI characteristics. So x-axis is the V and then y-axis is the I. So that's why it is called as a VI characteristics, or you can say about the static characteristics. So the characteristics of these two is almost same of that one. Okay. So okay, so next one we're going to see about the SCR and the GTO. So if you have see the first first developed device in the Thyristor family is the SCR. So it is developed in the year of 1960s. It is developed, okay, it is controlled on and uncontrolled off of the device, and then rating is up to it's a 5000 volt or 5 kilovolt you can say, and then 4000 amps ratings, and then nowadays it is a small of that manufactured wise, it's a the variations of that one, it is increasing few more of that voltages, higher voltages it is possible, and the frequency is the switching frequency is less than 1 kilohertz only. You will go to triggering okay, firing circuit, or you can say about the triggering of that SCR. Okay, so another is a force commutation is necessary for turn off of the SCRs. So you will go into force commutations or natural commutation methods you can use to turn off of the SCR. Then next one you have go for the GTO. So GTO you have seen it is developed in 1980. It is developed. The rating wise it is lower than the SCR. So it is a 4500 voltage only, and then current rating is also 3000 amps. But what about that one switching frequency? It is a switching frequency. It is a 10 kilohertz is reached on that ones. Another one is on-state voltage drop. Also compare with that one. The previously SCR it is on-state voltage drop. It is coming around 1.5 voltage on-state voltage drop. But here GTO is on-state voltage drop is 3 volt. Okay. So this is about the small difference in between the SCR and GTO. So if you have see the characteristic symbol of that one GTO. So GTO, this is a symbol of that one. Another one is the VI characteristics of that GTO. Particularly how to turn off of the device. Turn off of the device. So if you have go for that one GTO, it is a possible for the controlled turn off methods. So controlled turn off method is a possible. So how to you will going to turn off of the device means large reverse gate. So large reverse gate current, okay, normally 1/5 of the anode current, large reverse gate current you will going to apply. So how to you will going to on and off I will tell you here. So gate current, gate is a positive with respect to cathode is a negative. Gate is a positive with respect to the cathode is a negative. So when you will going to apply gate is a positive with respect to cathode is a negative. So you will going to turn on the device. You will going to turn on the device for it is common for GTO as well as SCR. You will going to turn on the device. So if I have increased that one, so you will going to apply the gate is a positive with respect to cathode is a negative. You will going to turn on the SCR. You will going to turn on the SCR. So you will going to increase the gate to cathode current ratings. When you have will going to very smallest current means you will going to this variation you will going to see. This variation you will going to BBO. Okay, break over the waveform it will come like that once. So suppose you are going to okay, gate current is very high. So I mean it is equivalent to that latching current means immediately it will going to come from that one 0 to straight, it will move straight to that once. So like it will going to move. Okay, coming to the point, turn off of the method. Turn off of the method means gate is a negative with respect to the cathode is a positive. When you will going to apply for that one, what will happen? So you will going to okay, reverse current is apply for that ones. So very large reverse gate current, very large reverse current. What is a large 1/5 of the anode current you will going to apply? When you will going to apply for that reverse current, so it will going to turn off. But this is a method is not applicable on the thyristors. Thyristor you can't to turn off, because thyristors once it is a turn on you can't to turn off. So either you can go for that forced commutation method or the natural commutation method. You will going to turn off of the device. So natural commutation means you will going to reduce the power on the anode to cathode. Okay, once it is a yeah, I'll go to the next slide. Yeah, once you will going to apply for that one, once you will going to trigger the gate terminals, so it will going to trigger the gate terminal, or you can say about that the current is equivalent to that latching current. So the thyristor will going to start to conduct it. Minimum current is required to turn on the SCR. Minimum current is required to turn on the SCR, that is called latching current. When the current is going below the holding current, hold. So you in that mobile phone or you calculator also hold button is there. Hold means freeze. So freeze means that one screen is it will going to freeze. Similarly, holding current means it will going to turn off. So when that one minimum current of that holding current, automatically the thyristor is turn off. Okay, so in that thyristor, what about that one means? So it is turn on only. So you will going to turn off means if you want to turn off, possibilities. One is so anode to cathode. Okay, anode to cathode, the power should be reduced. So when you will going to power is reduced, automatically it will going to turn off. Automatically it is turn off. This is called a natural commutation. Forced commutation means what is the forced commutations? So you will going to change the power supply. Cathode is a positive with respect to the anode. So cathode is a positive with respect to anode means force to you will going to stop. Force to you will going to stop about that device. So this is about forced commutations. Okay, so this slide it is showing for that one. Okay, how about the forced commutation is working? See here, there is a AC power supply. So you know that one AC power supply is a one cycle. It consists of the positive magnitude and a negative magnitude. See the waveform, it consists of the positive magnitude and a negative magnitude. What is a positive magnitude? So the top is the phase with respect to neutral. When top is a phase means the current is a flow, the thyristor will going to permit. So it will going to flow the current. When negative magnitude conditions, okay, the top is a neutral, bottom is a phase. When the current is a flow in bottom to top, okay, it is opposite direction. The thyristor is similar to the diode. It never permit to conduct. That's why it is a dash terminals. It's not conducted. Okay. So this is a method for that one, forced commutation. This is a method for the forced commutation. So firstly, what I want to do, I will going to give the gate triggering pulses or firing circuits. I will going to trigger that once. So it will once I will going to trigger the gate terminal. Okay, the minimum current is called latching current. I will going to reach the SCR is on. The device is on. So it will going to move the current from that phase to that SCR to the load. It will going to close the circuits. Okay, so in negative off cycle, what will happen? So bottom is a phase and then the top is a neutral. So when it is moved this direction, automatically the SCR is turn off. So this is about the turn off method. Okay, coming to the end of that one. So what you were seen so far, the difference between the GTO and SCR. What is that difference between the GTO and SCR? SCR is a controlled on and uncontrolled off. GTO is a controlled on and controlled off. So you want to control off means, so reverse current. The reverse current is a 1/5 of that anode current you will going to apply to turn off of the GTO. That's all. Thank you.